everyone. This is going to be a week 3 kind of review and kind of adding some stuff to our current game just to give you more experience with how everything works. Today we're going to be just reviewing the refactoring we did and some of the input stuff that we did as well, and then we're going to be adding some stuff to our game to make it more interactive. So overall, the main thing I wanted to review today was our polygon and our transform. Um, so first of all, these are in our engine components because they're universal in nearly every game. We're going to be expanding on this today as well to do a rigid body component, which would hold velocity. That's going to be for the future. And what we do is we just set up position and rotation and scale. And this will let us do everything and anything that needs to be done. So say we need to change the position, we can then go to our game objects and do the transform, or even in our components, we can do the transform. And this will get us this transform. And then it'll give us the position by doing dot position dot x or dot position y. Now we're doing a new polygon. So we have this new polygon component. So rather than having a draw and for every single game object, now we can kind of generalize this a little bit more to have just a polygon component that can draw anything. So with this, what we do is, I should also clarify for transform, inside of our game objects, whenever you create a game object, you create a transform because every single object needs to have a position, a scale, and rotation. So those are kind of the key things as well. Okay, now to polygon, not everything. So there are things like invisible game objects that do not really need a polygon to represent. So that's why we don't have it automatically added in the game component or the game object instantiate. But what we can do is it is useful to have it generalized. So in order to actually do this, what you would do is you would have to add the component. And when you add the component, you also add a fill style. So inside of add component, one thing that could be useful to you guys, if you hold Command on MacBook and click Component, it will take you to that. And in here we have this dot add component. Add component takes a component and just a list of values or a dictionary of values. And what this is we push that component. We set the component's game object to this, and we assign that component these values. So what that basically means is all these values that we input, we just throw it at that game object, and then that game object handles it. So in this case, when we say fill style of blue, what will happen is that it will take those values and say, oh, there's a fill style here. We just set that equal to blue. So now instead of it being magenta, and now in that instance it says it's blue. Which so now we kind of reviewed those two things. Let's review instantiate. So with instantiate, all this is just a standard way to add game objects now. So now we don't need to do this game objects.push. We just do instantiate. And we also give it the position, and then since game objects automatically have a transform, every game object is gonna have a transform to begin with and therefore position, so we can manually set the position. Otherwise, it'll just be at 0, 0, because in our transform, we have it as position equals new 0, 0. And then the final thing that we did that was pretty important were inputs. So with inputs, what we did was that we have a keys down and a keys up event, or that takes an event, and these functions are called when we do when we have an add key event listener or add event listener. And what it does is it just says, hey, whenever, so this is a static string where it recognizes and says, hey, whenever a key is down, fire this event. And in the event, it then shows up, or then as the input of a variable when firing that event, which is just representative of what key you're pressing down. And then we check if it's not included, because if we're holding a button down, what will happen is it'll continuously add to that keys down list, which is something that we don't particularly want. We just want an instance of each key. And then what we do is if it's down and it's not in, then we push it to the push to the keys down array. And the same thing for keys up. When it detects there's a key up, it calls this function. And then what we do is rather than saying remove, we have to do a workaround where we filter to where it is everything except that event.code that we received from the computer. Overall, that's the kind of the big picture. We can even go in a little bit on how we change it now. But now instead of doing this .gameObjects.push, we just do this .instantiate and then have a position attached to it as well. For game objects, now we just do add component. Oh, and then we always set the scale up at the end. Same with this. And now for triangle, now what we do is rather than having a local position, we always access this .transform.position for everything. One thing that did happen was that with this new way of doing it, we can only know the scale X, scale Y. So there can be some things kind of tricky with that. Okay, so this is where it can kind of get confusing until we get hard-coded collisions. But currently, what we have is we have a game. And right now, if you hit against the wall, you might not really be up against the wall. This is kind of going to be a common issue with collisions right now because it's hard-coded, so it's a little weird. But if we do look back at our rectangle controller, so obviously what we're doing is we can also do polygon. What we're doing is we are starting on the furthest top left position. And then what we do is we add to the X and add to the Y in order to determine where it is. And this is determined by doing the scale, this .transform.scale. And that determines where the next points are placed. So all we're doing is expanding, generally speaking, downwards, which is in the positive Y direction, and rightwards, which is in the positive X direction. What this means for our game specifically is that if we go up here, or if we hit this wall, that is just hitting our transform at the X at 0 or at our base index. So if we look into our code, so when we do arrow left, we don't need to account for scaling because we're not scaling towards the left direction. We're only scaling right and down. Now, if we had a negative scale, which I would highly not recommend, but if for some reason you needed to do that, then you would have to account for something here for a negative scale for your drawing your shape. for specifically your poly, now your transform, your scale. But since we're not doing that, we don't need to account for the left direction. Same for arrow up. We don't need to account for scale in the up direction because all we're doing is scaling down positively. So when we go up here, it hits right on that edge and you're good. Now, the tricky parts are if you go all the way down here and all the way right over here. So how would you adjust? Well, currently what I have is if you have your arrow right and the transform of your x plus your scale is less than canvas dot width. So what this is basically saying is that if we, let's actually get rid of this and let's get rid of this to see what would happen if we didn't have this. Now, if we didn't have this, you see how we can go off the screen now? That's because it is only tracking this top corner. And same for over here. What I'm basically doing is I am now, when I do this plus this dot transform dot y scale and this dot transform dot x or scale dot x, I'm basically adjusting for the correct position. So when I do this dot scale dot x, I add over the x. So now it's referencing this point so that when I go over there, it generally hits is correct. Same for the y. When I do the y, it does down there and generally hits it. So now we can't really go off screen. Obviously, it's not a perfect solution, but it is one that is simple and very effective. Okay, let's do some coding. So say I wanted to add a teleport or like a, yeah, let's call it a teleport. What we can do is first we need to see what the space button is in the for input. So if we go to input.js and we do console.log event.code, see what space is. So if we go into here, open live server, go into here, and now we do this. And so it's just called space. So let's do this. If we go into our rectangle controller and we can do if input.keysDown.includes space. Let's just add it to the X. So let's just do what would be the best way to do this? Because yep, let's just do this dot transform dot position dot x plus equals 20. So then this means that when we go over here and we click X, now it's plus equals 20. And I will show you that I'm just pressing spacebar for this. Now I have a quote unquote teleport. But now we get to some issues. What if? Oh, now we're off on the screen. And now can we go back? Yes, but we would be off on the screen. So what we need to do is we need to do some logic in our rectangle controller component. So in this case, we would do, and what we need to do is we need to get the current position. Let's make a negative statement in here. And what we need to do is we need to get the current X position, position dot X. And if we do plus 20, let's create a variable called teleport distance. Now if we do teleport distance and we do plus teleport distance is less than, well, it would be canvas dot width. Now if it's less than that, we can teleport to 20. Oh, now if we go over here, and now if we go over here, we press spacebar and something breaks. It says that teleport distance is not defined. Okay, we'll just do this. Okay, so now all it does is it just, when I click spacebar, boom. But obviously, we don't want a user to do this, where if we just, that's kind of unintuitive and ruins the fun out of the game. So what we would want to do is we want a cooldown. Now, this is now kind of getting a lot. So what I would do is I would create a new component called rectangle teleport.js, and I would include all of this logic. But since we're still kind of low in the terms of how big the game is, I think it's currently fine to kind of do this. But what you do is you would have a cooldown. Let's see. Let me double check. Okay. I also see what I did wrong with this. We can change that. And the instance of teleport distance needs to be this, not teleport distance. But so now let's do this. Now let's say teleport cooldown equals 200. And what we do, if it includes space and this dot teleport cooldown. So now we're trying to see if the teleport cooldown is greater than let's do and let's do something to keep track of how much left. Let's do cooldown left. Okay, so now we have a teleport distance, a teleport cooldown, and teleport cooldown left. So if this dot teleport cooldown left is greater than this dot teleport cooldown. So now what we're saying is that when teleport cooldown left it should, I don't like this naming convention, but I think that should be fine for right now. So it'll be, let's do teleport last use. Okay, so now teleport last use, when you last use the teleport. So when you say this teleport last used is greater than this teleport cooldown. So when the last used instance of teleport is greater than your teleport cooldown, then you can teleport. So now what we can do is now we can just now we need to keep track of last teleport use. So obviously it's instantiated to 0. So we can do those. We can do teleport last used plus equals, isn't it, time.ms. Let's see. Okay, this is going to require a little bit more. So what we will do is we will just plus 0.05 for right now. Well, no, because that's 20. So if we reach 60 frames per second, it would be 1/60th. And then let's do a 2-second cooldown. So let's do 2. All right, so I just did some quick math. So when we try and use request animation frames, we try and do 60 frames per second. So this means that we will add this 60 times per second, and I want a cooldown of 2 seconds. So that's why I put it 2 there. This is a temporary kind of fix / solution, but this should work. So now if we go over here, you can still spam it. Let me double check. Okay, we can still spam it. So now what we can do is we can console.log desktop helpful last use. We can do last use. And we can kind of see what's happening. So we should do this outside of this if statement. I see what's happening. Okay, so now we have the cooldown we do last use. We don't reset this equal to 0. So if it's valid, we have to reset this equal to 0. So now when we press it, now we do plus equals 20, and we kind of see that the distance isn't good. So now we can just go up to distance, and we can say 50. Now we can continue increasing this. Let's go like a super. No, you can't do super big. Let's do 200. All right, now let's go. So now we can go, press it, set it, resets it equal to 0, and we see our last use gets reset to 0. So now we kind of have a teleport only in the X direction, but we can kind of continue further. But now what we could also do is change it for each individual direction. And now instead of doing this, rather than assuming that it's going left, what we could do is we could do something like move this if statement into here. What this will do is it's basically saying, hey, if you're going arrow left and you teleport, if you're going arrow left and you teleport, what we'll do is rather than doing plus teleport distance, we'll do minus teleport distance. Now this is gonna get kind of messy. So what you could also do is you could do teleport change equals new vector 2 0 0. And now what we can do is now rather than doing this plus equals, now rather than this, we could just say, or we could even do a function. Yeah, let's do that. Let's say teleport. And we will have a direction. Okay, so now what we'll do is we will reference we don't need that. Okay. We will just do this 4 times. So now we would say we could redo this if statement, or you could have a direction where it says like if direction equals north, or I should say positive y, since there's no else if direction equals negative y, else if direction equals, let's do negative x, and we will do else, so that when if no keys are being pressed, we just assume the positive x direction. And now what we can do is we could now let's do this in here. So there's kind of two ways to do this. You could kind of include the space bar in here, but what I would do is I would do if input dot key down dot space. So now we're doing a space bar where we're saying, hey, if it's space now, or if the inputs include a space, then we just teleport and we give it a direction. And in this case, this would be positive x, but you could do positive x. I think for the sense of consistency between all of them, I will do this just so that it kind of matches four directions, and then we have an else that we can just copy and paste. But okay, so now we have if this dot this space, we teleport in the positive x direction. Now we can do something like this. And again, this would more than likely be its own component. Like you could have like a movement component or something of the sorts, and then you could kind of put all of these together. But for the sake of the video, we will kind of keep everything together. We don't need last use anymore. And now we just need to do this. So now now we have the logic for if it includes space. And we can even include this teleport cooldown in here. So we can do this. And then since we'll always need to teleport, we will do in here is then we will put this here so that we will say, hey, whenever we teleport, we call this function, we handle everything and teleport inside of this function. And now for x stuff, we could now for positive x in this last one, we don't need that. We could do this. So now we say if the now what we're saying is if it's equals a positive x direction, which we send up there, where we assign up here and pass it through the method, we say this dot, we check the position, and now we just say, hey, if it equals, if it's less than canvas dot width, then we continue. We can get rid of that. And then, for example, now we do for negative x, we do if this dot position plus minus teleport distance is less than 0, or less than 0, right? So if you have your teleport distance, you subtract your you have your position. If you subtract teleport distance, what will happen is if it's less than 0, what we should do is we should set this dot position dot x equal to canvas dot width. So now instead of just not teleporting, we just teleport to the edge of the canvas and then stop. So we can continue with that. And now we do the same thing for positive y. Now if it's dot y minus teleport distance is less than 0, this dot transform dot y plus equals teleport distance y. And then the same for canvas dot height, which I should probably do this one. Dot y, canvas dot height, dot y equals canvas dot. Okay, now we can kind of see. Hopefully this works. So we have, so obviously we got rid of that else statement. So if you wanted a base teleport, then you could do there. But so now if we go arrow right and teleport. Okay, so we go arrow right, we're going in the wrong direction. What about up? Are all these in the, did we do the wrong direction? Yes, we did. So we have to have negative there, negative there. And I think our if statement is also wrong because I think what's happening is that so if we did this dot transform dot y position minus teleport distance, this is a good time to fully flesh out sources. All right, so if we go to there, we go to your rectangle, and let's do teleport. Now if we reload it and we go there, spacebar, okay. Our game freezes. So last use is greater than there. We continue. It's not positive x, so it's negative x direction. So now we say the x position is 253. Our teleport distance is 200. I think there's something wrong with teleport distance. Yep, I see the issue. I was correct. It needs to be there. It needs to be valid, so that needs to go there. It needs to go the other way around. Nope, that was correct. Okay, let's try something. Now let's try this. Okay. Yep, so Y works. X doesn't work though. It goes the other direction. If it's negative X, it's going arrow left, arrow. Oh, that's why. I have those switched around. Arrow left should be negative, and then arrow right should be positive. And now if we go over here, and now we have that, and now that's correct. So now we have like a teleport, and now we can also we can't teleport diagonally because these are if else's. So if we just change this, now we can teleport diagonally. So maybe there. Nope, we are still not. It is because this dot teleport last uses. Okay. Okay, so what's the reason why we can't teleport diagonally is because what happens is that when we do this dot teleport, we set this dot teleport last use equal to 0, and therefore when we go back to our next arrow key, what's happening is that last use is less than temp cooldown or teleport cooldown, so it doesn't work. So when you click on it, it sets it equal to 0, so if we do input arrows.left, so say we're going right and up, we're doing these two, what's happening is that if we do teleport use, if we can teleport, it teleports, but then when we say equals 0, the next if statement, it's saying, hey, this is now 0, so we can't teleport. One way to do this is we could do a teleport mark. So as teleported equals false. So now what we can, instead of doing this, we could do this dot has teleported equals true, and then we could say if this dot has teleported, yeah, we could do that. Okay. So what we're currently going to do is we're just going to currently make like a little flag. So we do this, we move this dot teleport last use in here, and we just mark this as true. This dot has teleported equals true, and we do this dot teleport false. Okay, so now what we're doing, I want to, so rather than keeping track of if this dot teleport last use is greater than teleport cooldown, we set the last use to 0 automatically. When we teleport one time, we look at it through the entire frame using a flag, basically, or Boolean. And what we do is when we teleport, what's going to happen is that we'll just mark that flag as true, which means that then that flag, if true, will then reset the last use. What that this means though is that we can teleport in that frame instantly or thoroughly. So now if we go back to our game, I still can't spam teleport, but now if I go down up, I can teleport diagonally now as well. So now I can, if we ever continue to dodge and weave stuff, bada bing, bada boom. So now we can do for the cardinal directions teleport, the eight directional teleportation this game, just to add a little bit more fun to it in interaction. But currently, so well, I don't think this was last video, but what I did was I put X speed and Y speed in the constructor so that everything can have a speed, a varying speed. We want to avoid using the constructor. So now that we have our our values now that we can manually assign, what we're going to do now is we're going to create a new engine component called rigid body. So if we go into here, we do rigid body.js, class rigid body extends component. And now what we do is we have one called, let's do acceleration equals new vector 2, 1, 1, and then velocity equals new vector 2, let's do 0, 0, just so that, let's do everything 0, 0. We don't know. But now we have our new rigid body. So now what we can do is inside of this rigid body is when we instantiate it for our rectangle game object, what we can do is this dot add component. Oh, we also need to make sure we add it to the HTML. rigid body. Okay. So now we have rigid body. Yep. Now we go back to a rectangle. So now we do this dot add component, new rigid body, comma, and what we'll need to do is we'll need to do it's a lowercase v, so velocity is a new vector 2. And in this case, we can have the x speed, y speed. So let's just do x speed, y speed. Okay. So now, hopefully, when we instantiate it, we can grab this vector 2, which means that inside of our rectangle controller, we don't need x speed, y speed anymore. We don't need which means we don't need the constructor anymore. So we don't need any of this. Now we can remove the constructor and it follows Unity's model of only start, update, and draw. But this means that this is also going to have to change. So obviously we need to find that component, but how do we do that now? We need to find a specific component. How we've done it in the past is that when we do inside of our game object, we have a get component where we have a component name method. And what this is going to do is it's going to be, it's going to look through, it's going to go through our components. So we have to first get this, and it's going to do the dot find. And what the dot find does is says, hey, out of all of these, give me some sort of Boolean value. So where if it's true, I return that instance of it. In this case, it would be the component we're looking for. So if we have, and the syntax is a little bit different, but it's something we have done in class to where, so you basically have some sort of variable, you do a equal sign arrow, and then you do the Boolean statement that you want. So in this case, it would have to be component dot constructor dot name, and then 3 equal signs name. What this does, component dot constructor name does, is it gives you the name, this name. So if I was looking for triangle controller, I could do this dot find component triangle controller. In this instance, what we want to do for a rectangle controller is we want to do this dot find, or sorry, this dot game object dot how should we where is we don't okay, let's go like the game object. Yep, so we do component dot this dot game object dot get component, and it would be rigid body. And then let's console.log this dot velocity. It's not gonna work, but there's, I'm gonna see something in the console. Yep, it's undefined. Okay. So what we can do then is inside of our component, what we can do is we can then say get component return this dot game object dot get component. Okay, get component, then we input a name, and then we input a name here. Now, oh, is it because I don't have the return? Okay, yep, we don't need that. Okay, simple error. What I forgot to return the object that is found. So, but what now we have is now we go into our game object and we get the component based on rigid body, and and then when we console.log rigid body, now we have the acceleration and velocity of 5,5. And the reason why it's 5,5 now is because inside of here we have the velocity equals x speed, y speed, and when we instantiate it, we have a velocity of 5,5. So now we just repeat the same with the triangle game object. So now we can copy this into here. We can remove the triangle controller, rectangle controller, or constructor. Wait, yep. Now nothing is showing. Okay. That usually means a position is undefined. So let's go to our rectangle controller. And outside of the star, we also console.log this dot transform. Yep, so our position is now named for vector 2. Oh, I see what's happening. So we're getting the full rigid body, but we are asking just for the velocity, so we need to do dot velocity. Yep, and now that works. Now in our triangle controller as well, we can do this dot. We can copy and paste. And hopefully all works still. Yep, all works still. So now we follow the Unity API and we kind of get more experience with kind of adding specific variables and also now trying to find a component.